Welcome to my channel where we take a look at math problems that students often have issues with. Together, we will find that math can be easy. Today, I'd like to take a look at polynomials. Polynomials are super useful because we can do all sorts of things with them very easily. Many of these are related to calculus and we won't get into today, but we will talk about a few. So to start with, what is a polynomial? A polynomial is anything that has a positive whole number as a power for x. As an example, we have y equals, x cubed plus 3x plus 1. That is a polynomial, specifically a cubic. If I had instead, say, x to the fourth plus x cubed minus 1, well, that is also a polynomial, particularly a quartic. I could, in fact, change this. Now, it's a fifth power polynomial. Polynomials are always defined by the biggest power, because that's what does the most when x is big. So, the biggest thing to know is, are these even polynomials or odd polynomials? Even polynomials all pretty much look the same. Likewise, odd all pretty much look the same. For example, y equals x squared. We know that's a quadratic, and we also know it looks like this. Well, y equals x to the fourth is a very simple fourth power polynomial, and in fact, it actually looks the same as x squared. If you were to put these side by side, you notice there is a difference. X to the fourth is going to be a little more flat, like that. And the higher the power goes, the flatter it gets. So if I were to graph y equals x to 1,000, that's going to pretty much look like this, because it's so steep. But it still kind of has that U shape. All even-powered polynomials pretty much look the same. Having said that, there's a little bit of a caveat there. There are some middle terms here that this doesn't have. These ones don't have some extra terms, like the x cubed, x squared. Those terms, those lower power x terms do something. What they do is they add in some wiggles. And those wiggles are a little harder for me to just look in a problem and know exactly what they do. But, for example, if I have y equals, say, x to the fourth plus 3x cubed plus x squared plus 1, well, this 1 takes this original graph that looks like this, and it just says, okay, let's move it up 1. So instead of starting off at the origin, it starts off up a little bit. What these middle terms do is it allows for a little bit of wiggle. So, in the case of x to the fourth, it can have a wiggle. So it maybe looks like that in the middle. An x squared can't have any wiggles. But an x to the fourth can have one wiggle. It may or may not, I should be clear about that. An x to the sixth can have two wiggles. And so on and so forth. This x to the 1,000th, if I had a whole bunch of terms off there, well, then I'd see a whole bunch of wiggles around in here. So we talk about even powers. Well, odd powers are very similar. The only difference is you want to look at an x cubed graph as your example. So y equals x cubed, that looks like this. So y equals x to the fifth, you can guess, will also look like that. The only difference is this one is just a little steeper than that. Likewise, if I add in some terms, like say I have y equals x to the 7th plus x to the 4th plus who cares what. Well, this is a 7th power, so a third power has just this one wiggle. It could look like this. That's our first wiggle. And in fact, actually a linear equation is just a cubic without a wiggle. So an x cubed can have one wiggle, and x to the 7th can have 2 wiggles, or sorry, x to the 5th can have 2 wiggles, and x to the 7th can have 3 wiggles. So that might be what it looks like. It's hard to say exactly, but it has some wiggles. And so now you can look at any polynomial and have a pretty good idea of what it looks like. If you enjoyed this video, be sure to like and subscribe. If there's a problem you're struggling with, leave it in the comments. Maybe that will be my next video. If you're looking for a private math tutor, my email's in the description. Remember, math can be easy.